Hey guys, welcome back to the channel Campus Coders. Today we will see some application level questions from binary set. Okay, so let's see this question. I will say how what is given in this question in a short manner. Okay, so they are given an array which depicts the piles of bananas. Okay, so it means like this is one pile, this is one pile, this is one pile, and this is one pile, and each pile contains this pile contains 7 bananas. This one contains 15. This one contains 6. This one contains 3. So in that way, man. Okay, and they are given a time. Here it's given 8 hours. Okay, and now banana will be eaten by a monkey here. Okay, this monkey can eat uh, k bananas in 1 hour. Okay, each hour it can eat k bananas. We don't know what is k. That's what we're going to find. Okay, this k bananas the monkey can eat from only one pile. Okay, if it chooses to eat from this pile, it can eat only from this pile. It cannot move on to other pile within that 1 hour. Okay, and if the k is lesser than some greater than some value. Okay, let's say the k is now, let's say 4. Okay, and it chooses this pile of bananas. Okay, here there is only 3, so it will eat these 3, and the remaining one, it will not go to any other piles. It will just eat these 3 and be assets for that 1 hour. It cannot eat any more bananas in that hour. Okay, if it is greater, let's say if it chooses this pile, it will eat 4, and then rest of those lemon bananas will stay as such. Cannot eat the more than 4. Okay, it can eat maximum 4 bananas. Okay, this is what they are given in this question. So we need to find the minimum number k to eat per hour, so that the monkey can eat all bananas within this time period. Okay, we need to find the minimum number. So this is what given in this question. I will give a you know a gist of how this works. Let's say, for now we will take k is equal to uh, 2. Okay, we will check what is the how this question works actually. Let's choose this pile of bananas. This pile of bananas with k is equal to 2, the monkey can eat in 1 hour. It can eat 2 bananas. In another hour it can eat another 2 more bananas, and another hour it will take another 2, and just one banana is remaining. That will take another 1 hour. Okay, so okay, it will take another 1 hour. So this one takes 4 hours, right? So similarly, this will take how much hours it will take? It will take around 8 hours, right? Because 7 twos are 14. There is one more banana remaining. That will also take 1 more hour because it's from the separate pile. So it will take 8 hours. This will take 3 hours, and this will take 2 hours. Now, how we found these numbers? We just divided this number with 2, and then added plus 1, right? Whenever it's odd number. Okay, so this is how we found this. But here, this takes like around 4 plus 8 plus 3 plus 2. It is around 17 hours, but we needed to have it within 8 hours, right? So we need to find what will be the k. We can also take like example. We can take k is equal to 15. So 15, if it is 15, then it can eat this one in 1 hour, this one in 1 hour, this one in 1 hour, this one is in 1 hour. It takes 4 hours totally, which is less than 8. So 15 is also correct answer. But 14 can also be correct answer, right? 14 will take 5 hours. 14 is also an answer because 5 hours is less than 8. We need to find minimum such numbers. So there exists some number which is the minimum, right, in this possible categories. That one we need to find. So to have this, we can see what can be possible. So here, if we see, the answer must lie somewhere between 1 to the maximum of this array, right? Because since maximum is 15, it can if we take k is equal to 15, then it can eat every piles in 1 hours, right? If it is 16, still it can eat every piles in 1 hours. It doesn't matter if it is 15 or 15 more than 15. So our answer somewhere lies within 15. We don't need anything greater than 15, because anything greater than 15 is equal to 15, and we need a minimum number. So we are taking 1 to max of the array. Okay, this is the answer range which we can say. Okay, within this answer range only somewhere our answer is going to like. So what we can do is we can go through a loop from 0 1 to maximum of this element, check each and one. We will calculate the horse time, how much it takes for each and every element, and then check whichever is minimum, we can return that. That's the brute force approach. I hope you got that. We will see the brute force code once. Okay, so minimum rate to eat the bananas, it let's say have, let's first we will find a maximum of this vector. We can just loop the have a for loop and then find the maximum. It is, you can do it on your own how to find the maximum of array. We will get that and store it in maxi. Now what we will do is from 1 till the maximum element we will have a loop. Okay, and then we will calculate the time which is taken. So time which is taken can be done by dividing the element with hours, right? So if we divide and then find the ceiling value of that, let's say for example here itself we found if the pile is 3 and then time is 2, the answer will be some 1.5. We need 1.5 cannot be answered because it goes every hour wise, right? So we need, the answer would be 2 here, because for in 1 hour it will eat the 2 bananas. The rest one banana will also take the same one more hour, right? So it will take 2 hours. So we will take the seal value of the resultant division, and then we will add them each and every time. The total hours will be returned, and then if this total hour is less than or equal to h, we will return that uh, I, and then this minimum value will be returned finally, right? So this is the way brute force approach. The optimal approach would be obviously to use binary search here, since we know the answer lies somewhere between 1 to max. See here in brute force approach we are traversing through all the possible answers, right? Since the array possible answer sub range is uh, a sorted array, we can use binary search. We can have this as start pointer, this as end pointer. We can have a mid. We can check. We can do calculation only for that mid, and then see if that is less than if the calculated answer is less than the required answer required house, or if it is greater. If it is lesser, then we can see to the left side of the subarray and check if there exists some other possible answers or not. If it is greater, then obviously the right side part is not going to work, right? So in that way we can do. So we can see the optimal approach as well. Same, we can have lower index and higher index. We can apply the binary search. We can have the mid value, and then for mid value alone we can calculate the same finding the total hearts percent hearts. And then if that total hearts is less than h, we are going to check only in the right, left side part of the array, right side part of the array, and then if it is not so, we are going to check in the left side part of the array. So this is how this question works. This is how this is how the binary search is applied in this kind of questions. The first, the ultimate aim is to find the uh, subarray in which our answer lies, and that should be sorted. If it is so, then we can say that it's some related to binary search. So here's the next question. I will again explain the question what's given here. So they are given an array as usual. So what this array depicts is the uh, number of days it takes for this rose to bloom. Okay, these all depicts the number of days for a rose to bloom. Here there is a rose here, here, here in each every element, and the number in that element depicts the how much days it takes to bloom from starting from day zero. Okay, so this takes 7 days to bloom, this takes 7 days to bloom, similarly this takes 13 days to bloom, so similar like that. Okay, and they are given an number 2, m equals to 2. M means we need to create m bouquets. Okay, at least m bouquets we need to create, and k is the number of roses that should be contained in a bouquet, right? So this should be adjacent as well. So let's say if k is equal to 3, there should be 3 roses that are adjacent in this array, and that will make one bouquet. Okay, this that's how this question is given. We need to find the minimum number of days that's required to make at least this m bouquets. Okay, so like here if we say first, if we see this question in this one, for first 7 days there is no roses that's going to bloom, right? Only in the seventh day these four roses are going to bloom, and then this one rose is going to bloom. So in the seventh day, out of these five roses, these four in this four, there is three adjacent roses. So these three make up one bouquet, right? So in the eighth day there is no change. Ninth day there is no change, and it comes to 11th day. 11th day there is another rose that's blooming, but it's not adjacent to any other bloomed flowers, so it's not going to make any other bouquets. And then 12th day there is going to be another rose that's going to bloom, and now these three is going to make another bouquet, right? So this is going to make another bouquet. We need to get two bouquets minimum. So we got those two bouquets. So in the 12th day we got the minimum number of bouquets. So the minimum number of days is 12. So this is how we it is as this for us to find out. So I hope you understood this question. So again, in this is such questions you need to find the answer subarray range. Okay, so this answer contains in the range of minimum to maximum. How is it? Because till the minimum here we know, as I told earlier, till seventh day there is no roses going to bloom, right? Seven is nothing but the minimum element. So till the minimum element there is there is not going to be a single going to bloom. So there is no bouquets that's going to be possible, right? And then the maximum element is 13. By 13 days every rose are going to bloom. So that's the maximum possible days, right? After that, how many days we are waiting, the same number of flowers are going to be there bloomed, right? So the answer subarray range would be between min and max. So as we did the earlier question, we are going to traverse from minima. The brute force will be some by traversing from min to max, finding calculating all possible answers in each elements, and then find the minimum number of days out of that, right? But here yeah, that will be the time complexity will be high, so we are using binary search. The usual, we will have start pointer here, end pointer here. We will find a mid, and then for each mid element we are going to calculate the required answers, right? So here, how are we going to calculate the required number of days? That's the question, right? Let's see how this is done. So in every element, let's say we need the adjacent number of adjacent roses count, right? So what we will do is in every time we are finding a mid element, okay, we are assuming that to be answer for that time, right? So let's say if here min and max is 7 and 12, we are finding the mid element that's going to, sorry, 7 and 13, mid element is going to be 10, right? So we are assuming 10 to be the answer for that particular time for now. Okay, for now we are going to assume 10 as the answer, and we are going to calculate this in this array. Okay, now in this array we are going to check the possible number of bouquets that's here. So first, by 7 days, these three is going to make one bouquet, right? So what? How to find these three are going to make one bucket, since because these three are in adjacent sites. So what we are doing is, if this number of days is less than the day which we assume to be, then what we are going to do is we are going to have a count. For now it will track the adjacent elements. For now it will be 0. So if it is less than by this require assumed answer whether the rose is bloomed or not. So 7 is less than 10, so by now 7 this rose would have bloomed, so we are incrementing to 1. So we'll go to next element. Again, it's 7, so we're incrementing to 2. Again, we are incrementing to 3. Okay, again, by now we got these 3, right? This is the minimum k element. So what we are going to do is we are going to have number of bouquets as 1, right? So then we will go to 13. 13 is greater than 10. So what we are going to do is now this adjacent is going to break, right? So this 7, this changes to 4 as well. So this bouquet count, I will say how this is done. Now 13, we got 13. This is breaking the count streak, because that by in 13th element the rose is not yet bloomed. So what we are doing is we are we are going to the bouquet count. In what we are going to do is we are going to divide bouquet count divided by the minimum number of roses that should be there in this bouquet. That's going to be 1. We are going to add this in the bouquet, and we are going to set count again to 0. Okay, and then in 11, 12, it's again still going to be 0 since it's greater, and then in 7 we are going to increment it to 1. Okay, and so after there is no more elements, so what we are going to do is we are going to add it in the bouquet array. 1 by 3, it's going to be 0. So the number of bouquets possible in 10 days is going to be 1. Since it is less than the required number of bouquets, so what we are, the answer will be lying somewhere greater than 10 days. Okay, so we are going to skip the left side part of the array, and then this way we are going to proceed. So I hope you got the idea of this. I will show you how this is done. So first what we are going to do is the we are going to have a find the minimum and maximum in this array, and then we are setting it to low pointer and high pointer. We are going to do the binary search. We'll have a mid value. Okay, so this is the just the impossible case. Like if they are given here 13 is the maximum number of days, right? Sorry, maximum number of yeah, maximum number of days is 13 here. If it is like the number of roses here is greater than the number of roses here as, okay, if the number of roses as be 6 here, and the total number of roses in this array is the length of this array. If the required roses is greater than the available roses, then the answer is not going to be possible, right? So that impossible case we are just writing it down, and then we are finding the minimum and maximum. We are doing the binary search. We are finding the mid element, and we are calling a function to calculate the required case here. Okay, so if we go to this function, um, we are having a count pointer, number of bouquets pointer, sorry, the counts variable, number of bouquets variable, and then we are traversing through the array. We are checking if that element is less than the array, the required, the assumed day here. If it is so, we are incrementing the count. Whenever this condition breaks, we are going to check on the bouquet count. We are going to add this value count by k. Why count by k? Because this says how many possible adjacent flowers are there, so that we can create an bouquet, right? If there are 4 flowers adjacent and we need a bouquet of 3, then it means this it's 4 by 3, it gives 1. So the only one possible bouquet is possible, right? That we are going to add it here, and then we are uh, again initializing the count to 0, so that we are in the next for upcoming sequence we are starting from 0, so that new bouquets are created. Okay, and then at the end of the array, if the count is still there, that part we are going to again calculate in the bouquet. That's again calculator, and then returning what's the value, like if the number of bouquets greater than the assumed greater than the required number of bouquets or not. That one we are returning. If it is true, then we are reducing the high pointer. If it is false, we are increasing the low pointer. So that's how this question is done. Hope you got the idea of this. last question of this video. I will explain this question once. So there is a shipment company. They are shipping goods. Okay. So given is an array of those weight of goods. Each goods weight is given in the array, and we need to ship all these goods within these many days. Okay, and then there exists a minimum capacity for the ship. Okay, we need to find that minimum capacity. Okay, let's say for now the minimum capacity is the 9 itself. Okay, the minimum capacity is 9, so it means it for in the first day it will ship 5 and 4. Okay, so first good and second good, by that time the minimum capacity is reached, so in that one day it's going to ship these two only. And then the next day it comes in, it takes 5, it takes 2, it's getting 7, and then it cannot take this 3 because it exceeds the minimum capacity, so it just ships these two goods. Okay, and then the day 2 is getting over, then day 3 it ships these two, and then day 4 it ships this, and day 5 it ships this. Okay, so by this way we are finding the minimum, that is the minimum capacity, and then the working is done. We need to find the least weight capacity so that you can ship all the goods. Okay, so it's the same kind of approach. So by now you would have got an idea, like if they have asked something related to the least weight or least number of days, minimum number of days, or something like that, it's most probably going to be a binary search question. And here, let's find the usual subarray range, answer range. Okay, so here let's say what will the minimum range. I would say the minimum range would be the maximum of this array. Why can't it be minimum of the array? So if we take the minimum of the array, let's say 2, so it means the capacity itself is 2. So if it is going to take the goods 5, okay, which has weight 5, it cannot even take because the capacity itself is 2. So the minimum capacity should be the maximum of the weights that's available, so that it can take that good in one go, right? So the minimum should be the maximum of the weight array. Okay, and one more thing, this sushi array of ship is in the order, and this order only it's going to ship all those goods. Okay, that's so one more thing that's given in this question. Okay, so the minimum answer is the maximum of the subarray, and the maximum range would be the sum of this whole array, so that it can take all these goods in one day and then ship and go. Okay, so maximum to sum. So this is the possible answer range. Okay, this is where the whole answer idea lies. Okay, first thing is to find the answer range so that we can proceed on with binary search. So now we found the answer range. We are going to do the binary search from this as start pointer, this as the end pointer. We are going to find the mid, and then we are going to do some kind of calculations in this mid, and then check if it is satisfying this condition or not, and then we are going to proceed, right? So that calculation which we are going to do is going to differ from one question to another based on what's been asked. Here how we are going to find the that do that calculation is, let's see that one. Okay, so here we are the answer, we are finding the minimum maximum element, and then we are doing the sum, we are doing the binary search, and we are calling this function. Okay, with the array and then the minimum mid element. So what we are doing is we are going to, here we are going to have a day uh, variable, and then load variable. Okay, so first we are going to see if this load. So here what we are going to do is we are going to check in this array this load, if this load plus the previous load, whatever we are going to calculate, if that is greater than the capacity or not. If it is greater than the capacity, then for that day the load is completed, so we are going to add day at that in that case, and then we are going to initialize load as the as that element. Okay, so whatever element we have, they are going to initialize that. If it is not so, if the sum is does not exceed the capacity, then it means it can go in the same day itself. So we are not going to do anything in the day. We are just going to add the extra load in this load pointer, and then we are going to proceed. So that's what is done here. So we are increasing the load to 0. We are going to traverse, where if load plus the weight is greater than the capacity, then we are going moving on to next day, and then the load we are initializing the new load here. We are going to remove that old load and we are going to initialize the new load. If else, we are going to add the new weight into the load. That's it, and then we are going to return the number of days. And here we are checking if the number of days is less than equal to the required d, then it means we are going to eliminate the write up. We are going to decrement the high pointer. Else, we are going to increment the low pointer. So that's it in this question. That's it for today's video. I hope you have learned a lot of things in this video. The links to the questions will be given in the description below. You can definitely check it out and practice them. You can follow me in LinkedIn and Instagram. The link will be given in the description below. So yeah, I will meet you in the next video. Until then, keep coding. Bye bye.